3 years ago, when cyber attacks were in the news, from retail to national security, our middle school students stepped up to learn more about cybersecurity. They're part of the Cyber Patriot program that is administered by the U.S. Air Force. This program inspires students to follow careers in cybersecurity or other STEM disciplines critical to our nation's future. Over 800 middle school teams compete throughout the U.S. and Canada. Of the 12 in Ohio, 3 are at Wellington. In the competitions, teams explore a set of virtual operating systems, Windows 10, Windows Server, and Ubuntu. Students assume the role of a newly hired IT professional in charge of managing the network of a small company. In that role, they must find and fix cybersecurity vulnerabilities while maintaining critical services. Part of the fun is scoring points for your team each time you succeed. Why is this important? Because cybersecurity is about protecting data, your banking transactions, your medical history, your passwords, every message sent from your smartphone. Because it's the future, our future, their future, a world more and more online. It's where your children and grandchildren will be spending much of their time. They will be protecting more than physical borders. They will need to protect our valued information. Yet according to a 2018 ISC study, there are almost 300,000 unfilled cybersecurity jobs here in the US, and a global shortage of close to 3 million. Yet females currently represent only 11% of those working in cybersecurity. Think of the potential job pool for girls encouraged and exposed to this field early. I've always believed that students, no matter their age, can take on difficult tasks, become experts, and show leadership if given the chance. I'll let one of my students, Annie Shen, tell you more about her experiences and the skills she is learning on Wellington's Cyber Patriot girls team.
I'm part of the all-girls cybersecurity team. My job is finding errors on the Windows 10 and Windows Server images. My teammate Anchi works with the Ubuntu operating system she learned on her own this year, running command line codes, while our younger teammate Annika helps with managing user settings. Cybersecurity involves a lot of thinking and navigating, such as the paths to errors so that we can fix them. One of the most challenging things is to keep going, no matter how frustrating the problem might be. Sometimes we know we have something else to fix, but we can't figure out what the error is, but we've learned to persevere. Taking notes, problem solving, teamwork, and researching on the fly while working under a time crunch are keys to our success. We also prepare by writing and organizing task lists on a whiteboard to help identify and correct errors we encounter during competitions. Some things that we can take from cybersecurity into our everyday lives are patience, how to use different operating systems, computer updates, working with files, and how to make our own computers at home secure. I have learned many different things that will keep computers secure, such as turning on the firewall, looking at your services, and not opening unknown files. Once, Anchi opened an unknown file called FishJar. It turned out that it was a malicious software that created sharks with lasers all over her screen. However, we are not afraid of making a mistake, but instead take risks and learn from our mistakes, even if that means starting over. My favorite part about my own cybersecurity experience is learning about file paths and the solutions to problems we might encounter during competitions. I can use what I learned about passwords, viruses, software updates, and more at home on my own computer. Yes, even kids can become cybersecurity sleuths, while also helping their family and friends stay safe digitally. I look forward to our semifinal competition tomorrow and a third year on the team next year. Thank you.
you know middle school students are becoming hackers, this is a great opportunity to highlight one of our upper school math classes. Cryptography is an innovative course open to any math student who has completed Algebra 2. Quite simply, this is a class all about making and breaking codes. If you recall your time in high school math, you likely spent considerable time factoring quadratics, graphing trig functions, or solving word problems, the likes of which now exist as math memes involving large numbers of pineapples being purchased. Cryptography is a forward-thinking and timely course in our highly digitized world. Cybersecurity and cryptography is a zero unemployment industry with millions of jobs needing to be filled. As Helen mentioned, we need to keep our data safe, and that data is so much more than your email password or my bank account. It is our airspaces, our power grids, and our defense system. Doesn't that sound like the premise to the 1980s movie War Games? The constant stream of news stories regarding the dangers of hacking and cybersecurity can be quite alarming. So here is a math class that brings history to life. We discuss how Mary, Queen of Scots, used her own coded messages to make plans to assassinate Queen Elizabeth I. Ultimately, things did not go as Mary planned. Alan Turing's story is told in the movie Imitation Game, and I suspect many of you have seen it. Disney managed to make cracking the Enigma, the encryption tool that the Germans used to send messages, look a bit easier than it actually was at Bletchley Park. In this class, we discuss the size of the key space of the Enigma, 10 quadrillion, to highlight just how ahead of his time Alan Turing was. We owe much of our progress in computers and computer science to him. Before I go much farther, it is time for a small, painless math lesson. Each method of encrypting or decrypting a message is called a cipher. In order to use a mathematical cipher, we must convert letters to numerical values. Let's use the universally known fact, math is fun, as a simple message. Yes, yeah. First, it is stripped of the punctuation and spacing First, it is stripped of the punctuation and spacing to further confuse a would-be hacker. Each letter is replaced with a number that represents its placement in the alphabet. Math is fun then turns into the string of numbers above. In numerical form, we can now apply ciphers, the math at the heart of this course. The most basic cipher learned in the class is the Caesar cipher, named for the man who used it often. This cipher adds the same value to all the letters. Above you will see I added 23. However, that now yields numbers larger than 26. Comparable to converting military time to civilian time, we use modular arithmetic to get back to numbers between 1 and 26. This can be an arduous process when the numbers are very large, so see me later if you want more of a lesson. To add an element of mystique to this class, students then use ciphers to encrypt messages to send to each other. I encourage them to find meaningful quotes or passages that interest them. Some students have encrypted passages from Dr. Seuss or Harry Potter, while others find poems or political statements of interest, and others just use silly BuzzFeed jokes or celebrity quotes. The excitement of encrypting one message for an unknown recipient and then decrypting one of your own is pure entertainment. Sometimes mistakes are made. It is a math class, remember. Arguments ensue, and the students have to figure out who made the mistake. This is problem solving at its best. Beyond the math and the historical relevance or sending meaningful yoga-themed messages, my favorite part of cryptography is seeing students discover the power of programming. They quickly see that writing a program is a far more reliable computational method than doing the math by hand. They are welcome to do all the calculations by hand, but they cannot beat Excel spreadsheets when it comes to speed. Every year, a few students in this class are also in computer science with Mr. Cruzan, and they have stood out as impressive cryptographers. In 2018, David Lynn's enjoyment of this class inspired one student to raise the bar with programming in 2019. And Gabe is here to show off his website. What is most impressive is that Gabe did all this work on his own. Just like the programmers before him, none of these students were asked to write these programs. This was not an assignment for this class. This extensive work of Gabe's was simply because he wanted to do this. He spent countless hours slaving over small mistakes, thousands of lines of code, and math formulas because he was highly engaged and motivated. I'm sorry, Becky, he wasn't outside. Yes, there are loads of websites out there that use every cipher I teach, but Gabe created one website with tabs for every cipher, and he wrote the code running this website on his own. Plus, user interface is easy easy to understand and quick for data entry. Take a look. Push. Yes. Gabe, let's start with that easy Caesar cipher. How quickly can you encrypt math is fun with a shift of 23? He needs 2 hands for that.
Boom.
Okay. Okay, I have brought some others for him to decrypt. So, I used a 2x2 matrix. Do you mind decrypting that?
Okay.
In this class, students use 2x2 and 3x3 matrix multiplication for ciphers. You can see it. Save the koalas. Yeah, it's over there. So the Z it has to have an even number of letters, so it adds a spacer letter in there at the end. Okay.
Yeah.
Last, I've encrypted a message with Gabe's public key for RSA. One more, Gabe. Can you decrypt it? This cipher requires large powers of prime numbers, and at this point in the course, many students use Wolfram Alpha as their calculator and Excel are now overloaded. RSA was created in the late 1970s by 2 computer scientists and a mathematician. It is still in use today and will likely be replaced by quantum cryptography in the near future. He's working on it.
Boom.
There we go.
Yes.
Okay.
Okay. Okay. I've wanted to take this class since I first entered the upper school. I would hear my friends rant about the struggles they had while writing their programs and also rave about how much fun they were having. When I decided to make my own website entirely from scratch, I wanted to go for a user-friendly interface. That approach no one else has done before. I spent days working on making it responsive, intuitive, and so that people would be able to easily use it. After graduating, I plan on getting my bachelor's degree in computer science because I've always enjoyed being able to make things and just enjoy the challenge of figuring out a new way to do it.
At Wellington, our passionate, engaged, and motivated students go above and beyond in manners that surprise, thrill, and amaze us. Nice work, Gabe.